My channel. So this is Hardhick.M.Gowda with you today, guys. Today we are back with another video of class 11th chemistry. So this is our lecture number 2 on the first chapter, some basis concept of chemistry. So in today's lecture we'll be starting the very basic, that's the matter. So I'm hoping that everyone knows what is a matter. So in simple words, if I have to say that matter is something that has mass and it occupies some space. Now matter is basically classified into basically in two manners. So first one is based upon the physical properties. Next one is based upon the chemical properties. So in the physical properties means it is based on the state it is the present in. So the state in solids, gas, liquids. So these are the three main classification of matter under physical property: solid, liquid, and the third one, gas. So here particles, the topic of particles, if I have to say that particles are tightly packed, this is very loosely packed. So this liquid is in between solid as well as gas. So I'll be writing it in the form solids. I'm writing the tightness. So tightness is more in solids than the liquids, and it is more in liquids than the gas. Space between the particles is less in which the state is solid first, second it is liquid, then the gas. In under chemical properties we still have two classification. So here I'll be writing base, pure substance. This is a mixture. So under pure we'll be categorizing them into basically three more types. The first one is the elements. Second one is the compound. Third one is the molecule. So what is element? So element is something that I can say a single atom of a particular element. I write single atom. What is compound? Compound is atoms made up of different types, basically a substance made up of different types of elements in them. Like there is two or more elements. Next, molecule, more than two atoms. Okay, two atoms or more than it, but it should have only one element. So you'll be understanding this better here. See, element, example H, O, C, etc. Okay, I'll take the example of molecule. H2, O2, S8, etc. Simple compound, H2O, CO2, NH3, ammonia and all. So these are the and etc. There are a lot of. So these are the examples of. So not examples of element, molecule and compound. Next, under this element we have further classification. So I'll be classifying them into metals, non-metals and the metalloids. those which exert the properties of both metals as well as non-metals are, and in metalloids, non-metals which, so those which gain electrons, these the metals are those which lose electrons. Hope you have understood. Those which lose electrons. Okay. So after this, let us see the part of mixture. I'll be writing it here. Mixture is classified into two types: heterogeneous, homogeneous. So heterogeneous is those mixture. See, basically mixture is made up of two different elements. Basically, two different things should be there. Then only we can say mixture. Okay, heterogeneous means there will be mixture of two, but the particles are evenly distributed, or else I can say it's uniformly its composition and the distribution is uniform. So I'll write uniform distribution. And in homogeneous, it's the opposite, non-uniform. Example of this, I can write salt solution. For this, the mixture of water and oil, two distinct elements which cannot be mixed. Or else sand also, you can say water and sand. So non-uniform distribution. Hope you have understood. So let us color this. Hope you understood. So mixture is here, element is here, and the physical, based on physical properties, the classification is here. Yes. Do like our videos, guys. So this is solids, liquids, gas, pure substance, mixtures. Under this we have compound, molecule, element. Okay. Under mixture, heterogeneous and homogeneous mixture. So after this is the very basic that you all know. I just summarized it. Okay. Yes. Next we will be studying about the basics, law of chemical combination. What is that? Law of chemical combination. So law of chemical combination. The first one is law of the first one is the law that says about the conservation of masses. That is simple. Law of conservation of mass. So this law says basically that the total, so when two elements react together and the product that is made, the weight of this product's weight, as well as the total product of these two elements, or the reactants, I can say, will be same. Okay, so I can simply write that in simple words. The person who made this was Lavoisier, or Antoine Lavoisier. So his name we have learnt it somewhere. It was in class 10 periodic classification. The very first attempt. That was like he classified on the elements on into metals and non-metals. That's all. So now he has also given this law, and what the law says is the mass can't be created nor destroyed. So mass cannot be created nor destroyed. Next, law of definite proportions. Law of definite proportions. So the word definite proportions. So this word almost gives you a small idea about what the law says. So the law says that whether, so let me take an example of H2O. The various, we can get it from lake, we can get it from rainwater, we can get it from tap. Basically, whether the sample taken, for example this X, is an organic or it's like the synthetic substance, whether it is made by the humans or it's an organic, or else I can say natural, the composition of the elements present in them will be exactly the same, and it should not vary. For example, H2O. So in lake, obviously H2O is there. Rain, H2O. Tap, do we get H3O and all? No, right? There also we'll get what? There also we'll get H2O itself, right? So this is what the law wants to say. So law says that any given compound always contains the exact or the same proportion of elements, contains the same, I can write exactly same proportion of elements. Sorry for the handwriting, I'll just erase it. Of elements, proportion of elements in terms of weight. See, let us calculate the weight of it. So molecular weight, what is it? 1 into 2 plus 16. That is the weight of H2O, right? So that is 18U. So everywhere it's 18U only. You just measure it, right? H2O, H2O, H2O. So in terms of weight, the proportion of elements is exactly same whether the compound is a synthetic or a naturally extracted compound. So this law was was told by Joseph Proust. He was a French artist. Okay. Next, the third law says that law of multiple proportions. Law of multiple, law of multiple proportions. So what does this law says is basically, it was given by Dalton in 1803. So what does this says means, like, let us take an example of two elements C and O. So when we react between them, or when these two react between each other, or let us take an example of hydrogen. So what do we get? We get H2O, or else sometimes we will be getting H2O plus 2, it is given by hydrogen peroxide. Okay, So what is this? So I am saying that two elements when reacted together is not necessarily said that it has to or it should form only one compound. No, it can form many compound, more than one compound. So the number of compounds that are formed, okay, the number of compounds that are formed should be having the ratio in the total masses. The masses should be the same, not the same in the sense ratio should be in very small numbers, or you can say fixed masses of each other are in the ratio of small whole numbers, basically whole numbers. So I'll write ratio is in small whole numbers. Okay, yes. Next, so understood. See, for example, let us take another example. CO2 is also formed and CO is also formed. Now let us calculate the weight of it. So weight, 12 plus 2 into 16. This is 12 plus 16. Now 12 plus 32 is 44, and this is 28. Now same, let us take out the simpler ratio of it. We are getting in the form of 44 by 28, 22 by 14, and 11 by 7. If you did this, is wrong, because I'm pointing out the mistake that most students tend to do. So when you take two different compounds but it is made up of same element, take that element, take any one element that has the number of atoms same in them. Here the carbon is having 1 and 1, oxygen is having 2, oxygen is having 1. So the number element that I can fix is carbon. So instead of carbon, I'll be calculating the weight of only oxygen. So 2 into 12, 16 and 16. So 16 divided by 2 into 16 is what? 1 by 2. So it's in the ratio of 1 is to 2. This is what the law wants to say. Once again, I'll be saying the law. If two elements can form more than one compound, the masses of one element that combine with the fixed mass of the other element are in the ratio of small whole numbers. So do keep this law in your mind. This is very important. Next, the fourth one is Gay-Lussac's law of gaseous volume. Law of gaseous volume. So same, gaseous and volume, it's related to something related to volume of a particular gas, not a particular gas, general gas. Okay, so this was given by Gay-Lussac in the year what? 1808. So that was 1803. Which one? Dalton proposed the law of multiple proportion. The Gay-Lussac's law of gaseous volumes is given in the year this one, and this is very important. Next, so what is this law stating? So I will write hydrogen, this is a gas, oxygen, this is also a gas. What's this making? H2O. Let us think. Okay, now this is in the form of gas and the gas. Okay, now let me take a very simple number, 100 milliliters. 100 milliliters of oxygen gas. 100, let us take the half of it, 100 milliliter of this gas, and the amount that the water vapor in the gas means water vapor only, right? So how much will you get? 150. If you are thinking, no, this is not the mass of it, guys. This is the volume. This volume can be anything. So I'll just write not grams, milliliter of what else got. So the volume here of these gases, that is H2 is to O2, is in the simple whole numbers. Have already wrote. So I'm just repeating the law. So when two or more gases are produced, when gases combine or are produced, okay, anything. So when gases are combined or produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are in the same temperature and volume. So this last sentence, same temperature and pressure, should be same, because see, if temperature increases, the volume obviously increase, because temperature is directly proportional to volume. Okay, and pressure is inversely proportional to volume. If pressure increases, volume will be decreasing, and if pressure is decreasing, the volume has to increase. Has to means is increasing. Okay, hope you understood. Yes. So this last sentence, the same temperature and the pressure, is important. Okay, I'll write it down. Okay, very, very important. If you missed out in this line in when you are writing this law, it's going to be very bad. Okay, next, the fifth law and the final law is that Avogadro's law. Avogadro law. Okay, who is Avogadro? You know the number. This Na is Avogadro's number. That is 6.023 into 10 to the power of 23. Okay. Yes. So what this guy, and this was given in 1811. So this Avogadro said that when so okay, let me take an example. Two gases and Y. So these are at same temperature and same pressure. This is basically the inverse of this law. So when these are in same temperature and pressure and should contain equal number of molecules. See, basically when this gas, okay, is kept in a particular container, this container, and this is also kept in this same container. Okay, don't go by the shape. Just let me. Okay, this is the two container. All gas is there here. Okay, gas is there. Now he says when it is at the same temperature, this and this. Okay, let me write it in a very easy way so that you can understand. When this is having T1 temperature and this is having T1 temperature, and the pressure should be also the same. Okay, so then it is said that the gases present will be in the same volume, or I can say it contains equal number of molecules. Okay, it has equal number of what? Molecules and moles are complete different terms. Don't get confused by this term. Okay, yes. So that's it for today's video. Hope you like my video. Subscribe to my channel, hit that bell icon. See you in next videos. Bye.